Hello everyone. My name is Gautam Iyer, and today I'll be demonstrating my project deep learning based real-time detection of browser in the browser phishing attacks. So before I step onto the demonstration, let me explain what is browser in the browser attack. So let me explain it with an example. So let's say we need to log into Amazon.com for some shopping. So as the first thing we do is go on to Amazon.com, and the next thing we do is sign in. So when we click on sign in, there's usually a small window, a pop-up, which will usually be a Google or a Microsoft SSO. And these small pop-ups are a browser in it as well. So that's a small browser within the bigger browser, which hence the name browser in the browser. So the attackers use this small browser as the pop-up, as the malicious pop-up to gather your credentials, because you will be entering your email and password into the pop-up. So that's basically the whole idea of browser in the browser attack. It is foolproof because it mimics the actual SSOs, the legitimate SSOs. There is no obvious redirection like other malicious links or anything. So in that way, browser in the browser attack is very dangerous, and that's a basic gist about it. As I said, why it matters, because it looks really identical to the SSOs. It is also zero-day attack friendly, and many more. So coming to the project overview, there are three main features for this project. Uh, One thing is a custom built Chrome extension, Chrome and Microsoft Edge extension, which will be detecting in real time, detecting the browser in the browser attack in real time, and also the Spring Boot based backend, and also an attack simulation page, which we'll be using later to demonstrate the project. Coming to the data sets, we'll be using a big data set of more than 400 plus samples, basically of custom pages, some legitimate pop-ups and legal pop-ups, and also some proof of concepts. So the three classes mainly, the three scores is 0 is safe, 1 is suspicious, and 2 is BITB attack, which I'll be explaining later in detail. So let me just show you the data set real quick. So this is the Excel sheet which contains all the data, a huge data set, and each row represents a web page with various combinations of the scores, thereby providing us the data for the model later. Right. Moving on, the uh, 11 features. So the features is as the title says, in order to judge whether the website is a BITB or not, we'll be extracting certain features from its UI components. So then it'll be around 11 features. It will be consisting of three different types. That'll be UI based, that is checking if it has iframe. Iframe meaning an embedded HTML page onto another HTML page. There'll be some behavioral and JavaScript based ones if there's a suspicious JavaScript or any obvious traps. So, and also network based, saying DOM similarity, the document object model similarity, or the size ratio, and the thing is off. Coming to the architecture, as I said, there'll be 11 features, observing the UI, the JavaScript, and the network, and also the backend with Spring Boot framework with Java objects mainly, but an ONNX model that will be an open neural network exchange model, which basically provides me with the tools necessary for the each website, unique for each website. This way it'll keep on regenerating and thereby providing a smooth ML model for me. So this model will return a class and a prediction for me, thereby which will have a certain response, as I said, a 0, 1, or 2 score. So if it's 0, it's safe, thereby showing green, 1 showing yellow, 2 showing BITB attack, that will be red obviously. So coming on to the implementation steps. So these steps I'll be discussing further in detail during the live demonstration, and also some of the results of the performance results. There'll be 95% accuracy and a 96% precision in the BITB detection, and also a latency of less than 1.5 seconds. And the typical flow is once the user opens the page, the features are extracted, sends to the backend, and the backend predicts, and thereby a response is given. So response will either be one of these three banners. So I'll come back to the conclusion later. So now going on to the code, let me just show you the backend real quick. I'll be using IntelliJ for the backend. There we go. So this is my Spring Boot framework based application, backend application. Here's some of the code. Let me explain you the controller code. For example, this will show you the API endpoint of the application. And then this is the model, the .onnx, and this is the CV, I mean the data set which I showed you previously, and this is the Python script which feeds the model the data. So before I even proceed further with this, let me just show you the front end. Yes. Yeah. So as I said, the feature.extractor, once you open this function is called, and there are certain features, there's 11 features which are gathered from each website, which is then sent to the backend. So here you see the pop-up. This is responsible for the banners, as I said. And the manifest.json file, this is one of the most important files in the front end, basically determining all the permissions, all the scripts, and the name, declaring all the names. So a very important file. So that's basic idea of the front end. Coming to the backend again. So as I said, the feature.extractor.js sends these feature components as a vector to the backend. So here the Python script receives those data, uses the data set to create the model, and thereby getting a perfect prediction. So now let me start the application, my backend. So the backend is up and running. Before I test it live, let me just test the API once. I'll use Postman to test the API. Here I have already I already created certain API calls so that it's easy for the demonstration. So as the name suggests, this I have already provided a custom feature vector here. As you can see, the scores, this should suggest that the page is safe. So let me just send the call real quick. As you see, the page is verified as safe, which means the prediction is right and the backend is up and running. Let me also check the suspicious one real quick. Check the scores. Prediction comes out as 1. So that means suspicious behavior detected. Let's go to the BITB attacks now. Let me just send the call, and there we go. Prediction is 2 and it's BITB attack predicted, and thereby giving the perfect outputs by the backend. Now, to test it live, let's go open some websites. Let me open, as I said, Amazon.com. You show website here. It shows as a page safe, which is true. And going on to the sign in, these are the pop-ups usually. So this also comes out as safe. And that is one example of a safe website. Now, in order to show the malicious one, I have already simulated some files for that, which I'll be opening them. Here we go. So now let's test a safe login web page. Just, yep. Let me just run the live server. And we check, it says the page verified as safe. This login page, a simple safe login page, which is good. It's been working. Coming on to the suspicious one with certain tweaks in the features, as you can see, certain overlays and iframe. Here you go. Certain features which are tweaked so that it's made suspicious. So which we'll say go live. So once there's a pop-up, it says suspicious. You see that? Suspicious behavior detected. It's the right pop-up again. Close the server. And now coming on to the main BITB attacks with all the features triggered. So let's say go live. So as soon as the pop-up arrives, there we go with a really quick detection of BITB, thereby showing how the application works, its effectiveness. That's the basic gist of the application. Okay. Now, so thereby I'll be concluding the demonstration here. So the final conclusion for this is the project uses a multi-layered approach wherein I use the UI elements, the network elements, and the script elements, which actually helps in detecting the BITB real time. Unlike the others, which bases on URL or reputation, which often fails in these cases, thereby this way I can be able to detect BITB much more effectively. And also because there is a framework ready, this has a huge scope for advancement in the future when it comes to the BITB attacks, multiple different varieties of features, and thereby a nice framework to set up for the future. Uh, with such good conclusions, there are also certain drawbacks where we have some rare false positives because these BITB often mimics the in-page logins of certain corporate companies, and scripts, as it says, the minimalist scripts may reduce recall, and yep, the for future work, as I said, we can expand the data set, we can even get a mobile browser support, and many more applications. uh, that is it for the demonstration. Thank you so much for following it. Thank you.